Okay, so on Monday, Tuesday, during the block day, we did that example of like trying to figure out margin of error for movies, and we did 2 standard deviations because we kind of got to the place where we said, hey, if that P is going to be within 2 standard deviations of P hat for 95% of my possible samples. Okay? So we did 2 times the standard deviation because that margin of error made the interval, quote unquote, right, capturing that true value 90% of the time, or 95% of the time. So, in some respects, our margin of error was made up of 2 components, the 2 and the standard deviation. Is everybody good? And essentially what that means is it's not always going to be 2. In fact, it's never going to be 2. That 2 was an approximation to kind of introduce the idea. Okay? So the margin of error is always going to be made up of something called a critical value and the standard error, which is really, really, really close to the standard deviation. Okay? It's not quite the standard deviation, but it's conceptually the same. All right. The ways the critical value, what the critical value is the equivalent of that 2, okay? It's based on something called that level of confidence. The way we were thinking it through yesterday, our level of confidence was 95%. We would expect our interval to be right, capture that true value 95% of the time. But sometimes what we might say is, hey, that at 95%, 2 standard deviations ends up being this really wide margin of error. Maybe we're okay being right 90% of the time with a narrower margin of error. So that level of confidence is not always 95%. It could be different things. And if it's a different number, then we use a different number of standard deviations. Okay? The standard error is essentially going to be our standard deviation formula. But we have a slight issue with that. Think back to when we created our intervals yesterday, Monday, Tuesday, whatever day it was, when Miss Lombardi ruined it, right, for Mr. Wyans' age. Okay? What was our goal? When we used a margin of error, we did that plus or minus 2 years. And the whole point, what were we trying to do? Did we know his age?
No. Estimate.
We were trying to estimate his age. Yes? When we're doing these, we're trying to estimate P, yes? Is everybody with me? We don't know P. So can I use P in my margin of error if I don't know P? Okay, so we're not going to use the formula for standard deviation because the formula for standard deviation requires us to know P. So we're going to use the formula for standard error, which has a little bit of error in it, because we're not going to use P. We're going to use P hat, because it's our best guess at what P is. Now, as I go through and I say I want to decrease my standard deviation, there's 2 ways decrease my margin of error. There's 2 ways I can decrease my margin of error. The first one is be less confident. 90% confident instead of 95% confident. But a lot of times, we don't want to just shrink that down, okay? Our other option is increase our sample size. Because what's going to happen if I have a higher sample size? My standard deviation will decrease. And so that will still make my margin of error decrease. All right. So if this is what I'm using for my margin of error, we're doing something called a one sample Z interval for P. That's like saying we're going to use the normal distribution. So saying we're going to do a one sample Z interval for P is just giving a name to something we're going to do. Okay? All right. Now, we call it a Z interval because that critical value we're going to use is called a Z star. The Z of Z star is no different than the Z's we've been working with so far, except for everything right now we've done with Z's has been like, oh, I have this one observation. What is the Z score of that observation? So it's for a specific thing. Z star is theoretical. It's not of an actual observation. It is a boundary of the possible P hats that we're dealing with. Okay, so because it's a boundary and not an actual observation, we put a star on. Okay, and the Z star changes depending on how confident we want to be in our answer. Remember when we said, hey, if we guess Mr. Wine's age plus or minus 5 years, we felt way more confident than if we did plus or minus 2 years. Okay, and just overall, a Z-score of an observation is its number of standard deviations away, yeah? That makes sense that our Z-star, our critical value, is times the standard deviation. Now, how many standard deviations do I need to be that middle 95% or that middle 90%? Okay? So, how do I find Z-star? What do we know about Z-scores?
Their standard deviation is 1 and the mean is 0.
We know they have a mean of 0 and a standard deviation of 1. And so if I want to find Z-star for a 90% confidence interval, what I know is that middle area is going to be 90%. And you guys notice there's essentially two Z-scores that bound that because we have to have the lower and the upper. Tell me, just looking at this picture, something about these Z-scores. I don't need to know their numerical values. What's the relationship between those two numbers? Not quite equivalent. You know what is equivalent though? This distance and this distance, right? If it's that middle 90%, what can we say about the value of this one? It's negative. The value of this one is positive, right? But so they're the same number, one negative, one positive, yeah? Okay? And if I know that's the middle 90%, what does that make this tail? 5%. And so are you guys with me that if I know this one, I also know this one? Okay. And so for Z star, we really, because what we do with the Z star is that margin of error, and we do plus or minus with our Z star for our margin of error. That's the whole point of this. We don't really worry about positive signs and negative signs. We just write out what is the number of standard deviations. And I don't even need your help with this. can't imagine it's anything other than 1.645. I could be wrong, but I'm pretty sure it's 1.645.
Is the Z star?
I'm listening.
No, I know, I'm trying to word your question. Like, because at first when we drew that graph, I thought we were going to be looking for the two Z's. But what is like the Z star value? Where do you see that on the graph?
This is negative 1.645. This is positive 1.645. So it is the two Z's. It is just,
So would you have to put plus or minus?
No.
No? Okay.
so the way we utilize Z star is our margin of error, yes?
Mm-hmm.
What do you do with a margin of error? Your margin of error for Mr. Wyon's age of 2 years, what did you do with those 2 years?
Oh, plus or minus.
So it ends up taking care of itself. If you wrote the plus or minus, cool. If you didn't, cool.
Okay.
I think the College Board would expect you to just write the positive version of it. Okay. And so the reason I put here, you guys, 90% and 99% and 95%, those are the three most common levels of confidence we use. So, guys, if instead I'm 99% confident, what would that make that tail? 0.005. And I bet I know this one too. 2.58. Yeah? They're used over and over and over and over again. That's why
No, I know why you know it. I'm just confused because my calculator is just telling me like a little bit, not that.
What is it saying?
Well, it's more than a little bit, 2.32.
Am I that far off? Could I be wrong?
No, I don't think.
Oh, did you do 0.99
Yeah,
and not 0.005?
that's the issue. Yours says.
I've been smart at least twice today. It's just surprising given my sleep pattern last night. One more. I slightly lied to you with the movie theater example of 2 standard deviations. It's not 2. For 95%. Something like 1.96. Not that I... How are we feeling so far? Okay. Next. All right. Now, this next piece is what the has to happen in order for us to be allowed to take our sample and make conclusions about the population from it. Okay? And so each of these different, we call them conditions, okay? Each of these different conditions are there in order for either us to be allowed to use a piece of our calculation or to make conclusions to begin with, okay? So in October, I'm sure you guys remember everything from October and you couldn't have forgotten a single thing, right? We talked about there's like, when you run a study, there's 2 things we need to ask ourselves at the end of it. What are we allowed to conclude and who are we allowed to conclude it about? Okay? And all of that came down to the randomness and how randomness influenced the study. So if I had an experiment that was randomly assigned to people, I was allowed to conclude cause and effect. But if that was done on a group of volunteers, I still wasn't allowed to conclude that about the population. When you think about a confidence interval, what we're doing, trying to use a p-hat to estimate a p, we're trying to take our sample and generalize it to the population. Okay? And in order for that to happen, the participants in a study need to be randomly selected. Okay? So, the reason, and this is going to be true for the next 4 months, because we're 4 months from the AP exam. Okay? For the next 4 months, random. The reason we need randomness is random samples can be generalized to the population. And so if we're trying to make conclusions about a population, we need our sample to be random. Okay. Y'all, we just talked about how to get that z-score to build our margin of error. And which operation in your calculator did you choose to calculate that z-score? Inverse normal. So we need the p-hats or x-bars, depending on what kind of interval we're doing, need to be normal. Because our calculation needs it to be normal. If we're going to use the normal distribution to do calculations, we need to, before we do so, make sure we've done that the study's set up that we can assume that normality is true. Easiest way to do that, large sample size. Okay. Right. Now, independence means that selection for the sample needs to be independent. It never is. Y'all, if I randomly select 3 of you, the probability that the first person is selected is 1 out of 12. I randomly select 1 of you. What's the probability that you're selected if you're not that first person? 1 out of 11, our probability of selection just changed. Is everybody with me? So technically not independent. We have a workaround for that. We'll talk about that in just a second. Okay. So when we do this procedure called this one sample z interval for p, okay, when we do that procedure, I want to take you through how to check it for this specific thing. Okay? The first thing is that the random you're just going to look for, is it given in the question? And you're going to say, hey, I looked and I knew my sample needed to be random, but I'm going to tell you it's random. You just need to tell me that you looked and made sure. Okay? Since we're doing a one sample z interval for p, we need the p hats to be normal. The normal condition for p hats was np, n1 minus p. What's the problem with doing np and n1 minus p? If we're trying to estimate p. You don't have p. So the normal condition here, we're going to do np hat and we're going to use p hat in the place of p. And then for independence, essentially, as long as our sample size isn't ridiculously big, okay? Imagine there are 342 kids in Grandview Heights High School. You guys, I'm not sure if you were aware of that, okay? Let's go ahead and say I'm randomly selecting 3 people. The probability that you are selected is 1 out of 342. Then I pick out the second person, it becomes 1 out of 341, then 1 out of 340, right? Are you guys with me that 1 out of 340 and that 1 out of 342, is there that big a difference between those? No. Now, if instead of selecting 3 people, I selected 200, my first one's still 1 out of 340. My last one's 1 out of 140. There's a huge difference. Okay, larger samples cause problems with independence. Okay, so as long as our sample size is small enough that even though that probability changes, it's not going to change enough that we're worried about it. Okay, and the definition of how small it needs to be is less than 10% of the population. All right. Okay. Now, on your formula sheet, you will not get the formula to do this interval. You will get this formula. This is written on your formula sheet. We're going to learn 5 different types of confidence intervals. All of them follow this structure. So they don't give you, this is how you find this one, and then this is how you find this one, this one, this. They give you this and all the formulas you need to get there. Okay? So, in this context, when we're trying to estimate P, a proportion, our statistic will be P hat. Because what do we use to estimate a percent of, like P hat and P go together. If I was trying to estimate the mean height of something, this would not be a P hat, it would be X bar. Okay, so just making sure you're picking the statistic that matches what you're trying to estimate. Plus or minus your critical value. Our critical value is the Z star. Then it's gonna say that standard deviation of the statistic. It's gonna have the equations for the standard deviations for each statistic. So you just gotta pick which one you're using. So I'm not gonna give you this formula. So this would become, I didn't space this well. P hat 1 minus P hat over N. Okay. So I won't give you this. I'll give you this and the pieces that you need to fill in, and you need to make sense of it. Okay? All right. Lastly, the intervals have a very, very specific interpretation. You're always going to start with, we are blank % confident, depending on what our confidence level is. All right. All right, y'all. So, you'll notice that I put these like weird boxes and stuff in my, when you guys go to the AP exam, first of all, Well, I can't guarantee you're going to have a one sample z interval for p. It's pretty much guarantee you will have some kind of inference on the AP exam, argue in the free response questions. I would make the argument that you'll probably have more than one question about inference. I don't know for sure. Okay? So the first thing I want to point out is all you're going to get is the paragraph, and you're going to be expected to remember a lot of things that you need to write down. In my experience, when I started teaching kids to use the boxes, it helped them not forget to write stuff down. Okay? Because you say, all right, in this box, what goes here? In this box, what goes here? In this box, what goes here? And made people way less likely to forget something. Is everybody okay? All right. So, in this box, we're going to do the procedure and conditions. In this box, we're going to do our calculations. In this box, we're going to write our conclusion. Okay. I got great news for this first quiz. There's only one possible procedure you could write down. Cool? It's the one we just named, called a one sample z interval for p. And then, as a general rule of thumb, we always define, when we write down a variable, we define what it is. This is going to be a picky point. The reason I'm going to be picky about this is it cost kids a lot a few years back if they forgot one tiny word, just because of where the rubric shook out and where kids ended up getting, a lot of kids ended up getting P's, and the way that affected their score all the way down the question. Do you guys get what I'm saying there? Okay. When we're defining P, what does P describe?
The population.
The population. So what people want to write is P is equal to the proportion of Grandview residents who agree with who want to rename the gym. What you need to say is P is the true proportion of Grandview residents who support renaming the gym. Now, a quick English question. Y'all, what verb tense did I write this in? It is in present tense, yes? A big mistake kids tend to do is they write it in past tense. And the minute you write it in past tense, it sounds like you're talking about the sample instead of the population. Do you guys see what I'm saying here? We really want to avoid, when we're doing inference, past tense verbs. It's like the easiest way to lose points is put something like, oh, at the end I say, blank percent confident, we're 90% confident that the interval from blank blank contains the proportion of Grandview residents who supported renaming the gym. If I say supported, it sounds like I'm talking about the sample, but I'm not making a conclusion about the sample. I need to make my conclusion about population. Okay. All right. Let's go through and check our. Before we do our stuff, let's start looking at some of our calculations, y'all. We're gonna need to know n and p hat here. So can you guys help me out? What is n and p hat? N is 513. P hat, you're going to show the work is going to be 372 out of that 513, which 0.725, perfect, okay. All right, now let's check our conditions. Is the random condition met? Yeah. Oh, you go up, you look, and you say, we were given it's a random sample. Okay, then what we're going to do, we're going to do NP hat, so that'll be 513 times 0.725, and then 513 times 0.275, and we should end up with 372 and 141, give or take.
Well, your 372 is a little off.
No, it's not.
371.95.
No, it wasn't. If you multiplied by, instead of 0.725, by the actual p hat, the unrounded p hat,
So
it's NP, when what you're doing is NP hat, it's going to end up, it's actually just, think about p hat is your number of successes over n times n. It's just your number of successes.
If you wouldn't have put 513 times 7, would you not get the points?
You need to show your work. It's annoying. It's super annoying. Last one, independent. You're just going to say, hey, 513. Our population is all Grandview residents. 513 is definitely less than 10% of all Grandview residents.
What about on questions when we don't have like the context of knowing? Like obviously we know that.
So typically they don't set you up for failure. They're going to give you a question like, oh, they take a random sample of 518 teenagers. I'm very comfortable saying 518 is less than 10% of all teenagers. If you, I'm comfortable with the phrase, it is reasonable to assume. Oh, let's just do that. Typically, the way you're going to be, they don't give you a question where this is what they expect you to do and not make the conditions met. But what they might do is give that whole paragraph, and part A of the question might say, explain why it might not be appropriate to run a one sample Z interval. And when they ask you that, you would say, well, the reason it might not be appropriate is those conditions aren't met. And then so that's your hint that, oh, when I check my conditions, there's an issue. And usually that would be a question that has like a part A, part B, part C, because then they'll have you do something else with it instead. Did that answer your question? I hate the beginning of teaching inference, but I love teaching inference. Like when we get towards the end and we get to actually like apply these in real world context, it's a little bit more fun. But the nuts and bolts at the beginning is hard. But you guys, a reminder, this is only hard because it's the first time. Okay? All right, you guys ready to do the interval? This is the fun part. Okay, so what is our best estimate for the percent of Grandview residents who support renaming the gym? 0.725, my p hat. Plus or minus. If I would like to do a 90% confidence interval,
1.645.
my critical value, that Z star, is going to be 1.645
Should we
times.
in the calculations define like Z star?
Remember we went over here when we wrote a one sample Z interval?
Okay.
That's how you're communicating that it's a Z star.
Yeah, I just mean like under the calculation, should you put Z star equals?
Nah, because we're in remember how I knew all the answers to the Z stars? They're pretty comfortable with that.
Okay.
And in fact, eventually you guys are going to learn a calculator shortcut. I have many a reason why I'm not showing it to you yet, but there is actually even going to be a calculator shortcut to the actual calculation of the interval. You guys, what am I putting under my square root sign here? I can't use P1 minus P because I don't know P, right? But I can use P hat, so we're going to do 0.725, 0.275, and 513. All right, so let's do this. If you have brown eyes, can you plug the minus version of this into your calculator? And if you have non-brown eyes, can you put the plus side of this into the calculator? But I don't see why we need to type it in over and over and over again. You know, it might be kind of fun for me to watch kids going in and out of the building today.
For the plus 0.0467.
No, you didn't.
Okay.
I got 0.757.
That feels way better.
I think I did.
But that's your margin of error. You haven't done the order of operations. Just do it all at once.
I know. I just get scared to do that.
Well, when you don't do that, you have a problem with your order of operations.
Wait, does that just multiply? Oh, right.
Yeah.
Just right next.
Or just put it down so she knows.
Okay.
Okay, and then for the lower, we should have gotten like 69.7% maybe? 0.697? 0.693? Oh, I'd buy that too. Because I was working from memory, not from reasoning. Does anybody else need help like figuring this out in the calculator?
Maybe. Wait, I put. I see what I did.
Okay, cool. We do it on a scale of 1 to 10. Scale of 1 to 5. How are we on the calculation? Okay. All right. Okay. And then all right. Now. Yeah. I really would suggest you type it all in at once and not try to do, like, because otherwise order of operations suggests that you have to multiply these two first, then take the 0.725 plus and minus your answer. Okay, so it'd be very, yeah. All right, and our conclusion is going to be a very, it's always the same. So we're going to start with we're going to state our level of confidence. What is our level of confidence here? 90% confident. At the interval from 0.693 to 0.757 captures, and this is another place, do not use past tense here, okay? Captures the true proportion of Grandview residents who support renaming the gym.